Bismillahirrahmanirrahim. I am Sidra Mehmood and we are discussing the course content of nuclear analytical techniques, in which we will discuss the topic of industrial use of radio traces, and this is our lecture number 18. The key concepts of this lecture include the industrial uses of radionuclides, the determination of flow rates and liquid volumes, radio tracers in wear and corrosion studies. So basically we are dealing with the radio tracers and their uses in industrial as well as determination of flow rates and in wear and corrosion studies. Now we will move towards the main topic, which is the industrial uses of radionuclides. So basically we are studying the use of radionuclides in industry. Now we will discuss the main concepts of radionuclides. That what are the radionuclides? The radionuclides or radioactive nuclides or radioisotopes or radioactive isotopes, they are all the names of basic same species, and it is considered as an atom that has excess nuclear energy, which makes it unstable. So it is basically an atom having an excess nuclear energy, and this energy is then can be utilized in different ways. Basically this energy is utilized in three ways, which is emitted from the nucleus as gamma radiation, can be transferred to one of its electron to release it as a conversion electron, or used to create and emit a new particle, which may be alpha beta particle from the nucleus. The conversion electron, we can say, is the electron which is released when a highly radioactive atom having excess energy ejects an electron from the neighboring orbital of an atom, and in this way electron is ejected, and this high energy electron is known as the conversion electron. And during these all processes, the radionuclide is said to undergo radioactive decay. So basically radionuclides are the high energy atoms that may undergo different conversion reactions, like they may emit gamma radiations, may emit alpha or beta particles, or may result in the conversion electron. And this uh, whole process is known as radioactive decay. Radioactive decay is considered as the process by which an unstable atomic nucleus loses energy by radiation, and as a result of this different uh, rays may be generated, like alpha, uh, beta or gamma rays, and they are different names given to these decays, like alpha decay or beta decay or gamma decay, and these all involve the emitting of one or more particles or photons. Now we will discuss the applications of nuclides. We will discuss different applications of different radionuclides. First of all, here we have the tritium radionuclide H3, which is the isotope of hydrogen known as tritium, and its main applications are that it is used as a self luminous in aircraft and exit signs. Just because of its reflecting ability, it can reflect and show a spark or luminous, due to which it is used in exit signs. Uh, it can be used in luminous dials, gauges, wristwatches, and luminous paints. Uh, these all are the luminous parts that have the ability to shine in dark. So whenever we are traveling on the road at night and we see the uh, signs, traffic signs that are showing the reflective properties, they are basically due to these luminous particles present in them. Then is the sodium radiotracer Na-24 or sodium nuclide. It can be used in the location of pipeline leaks, and it is also used in oil well studies. Then we have scatrium 46, and it is mainly used in oil exploration tracer. Likewise, it is the tracer which can detect the presence of oil in different areas. Then we have the radionuclide, which is of iron 55. It is used in the analysis of electroplating solutions and defense power source. Then is the cobalt 60. It is basically used in surgical instrument and medicine sterilization. Like sterilization is the process in which we purify our instruments, and it this cobalt 60 is mainly used for the sterilization purposes, and it is also used in safety and reliability of oil burners. Then we have nickel 63, and it is basically used for the detection of explosives. Uh, it can also be used as voltage regulator and current surge protectors. Then a nickel can have a vast applications in heat power sources. As we have studied it earlier, that different nickel alloys are used to make different wires, and so it has the uh, heat power durability, so it can be used in heat power sources. So now we will discuss some more applications of different radionuclides. We have a Krypton 85. It is basically used in home appliances as indicator lights. Then it has the use in gauge thickness of various thin materials. Gauge is basically an instrument that measures and gives a visual display of the amount, level, or contents of something. So it basically is used as a gauge thickness of various thin materials, and then this nuclide is also used in the measurement of dust and pollutant levels. Then we have strontium 90. It has a basic application as a survey meters. Survey meters are actually the survey meters are also considered as the rate meters, and they are used as a radiation protection. Uh, Survey meters in radiation protection are handheld ionizing radiation measurement instruments used to check such as personal equipment and the environment for radioactive contamination and ambient radiation. So, for different surveys of radioactive contamination and ambient radiations, these survey meters are used, and they use the radionuclide of strontium 90. Then we have cadmium 109 radionuclide. This radionuclide is basically used for X-ray fluorescence studies of metal alloys. Then we have the tracers of then we have the radio tracers of antimony. Antimony 124 and antimony 126, and these radio tracers are basically used in oil exploration studies. Mm, Different exploring techniques are being used to explore the presence of oil in different rocks, different sea level at different sea levels. So different techniques having different radionuclides are being used to study the uh, contents of oil in different areas. So both of these isotopes are used for oil exploration studies, and they are considered as the exploration tracers. Then we have iodine 131, and this isotope is also used for petroleum exploration. We can consider it also as an oil exploration tracer, as petrochemicals are all the organic substances, and iodine 131 tracer is basically used for the petrochemical explorations. Then we have CS136 and CS137 isotope, and CS136 is also used as an oil exploration tracer, while we have CS137, and it is used to measure and control the liquid flow in pipes, and it is also used to measure the oil well plugging by sand, like different pipes clogged, or uh, they become filled with sand due to the sand particles present in oil. So those sand particles sometimes clog the pipes. So these tracers, basically CS137 is basically used to measure the oil well plugging by sand, and then it is also used to measure the fill level of consumer products. Then we have barium 140, and this barium 140 is also used uh, as oil exploration tracer. Then we have PM147 radionuclide, and it is used as electric blanket thermostats, used as gauge thickness of thin materials, and it is also used as oil exploration tracer. Then we have SM151. It is used as a heat source radionuclide. We have EU156, and this radionuclide is also used as oil exploration tracer. Now we have some more radionuclides, and we have IR192. This radionuclide is being used in the pipeline, boiler, and aircraft weld radiography. It is also used as oil exploration tracer. Then we have the isotope of gold, AU198. It is also being used as oil exploration tracer. Then we have thallium 204, TL204, and it is also used as a thickness gauge. We have discussed it earlier that what is gauge. Gauge is basically an instrument which can measure the different virtual images for any object, so it can determine it, or it can be used as a thickness gauge. Then we have polonium 210 isotope, the radionuclide of PO210, and this can be used as the reduction of static charge. Then we have thorium isotopes. Different isotopes of thorium have different applications, like thorium 229 extend the life of fluorescent lights. Uh, like we have different energy savers being used in our home, so their lifetime can be extended by using isotope of thorium 229 in them. Then we have thorium 230 isotope, and it is used as coloring and fluorescent in glazes and glass. And we have thorium 232. uh, it with along with tungsten is used in electric arc welding rods. Different welding rods using is having different electric arcs are being used for welding purposes, and basically they use the tungsten isotope, but along with tungsten, to increase their efficiency, different isotopes of thorium, basically TH232, is being used. Now we will discuss the application of uranium 235 radionuclide, and this radionuclide is being used in a nuclear reactor as a fuel, and it is also being used in fluorescent glassware, glazes, and wall tiles. Glazes are basically the layers or coatings of a vitreous substances which has been fused to a ceramic body through firing, and a glaze can serve to color, decorate, or waterproof an item, and glazing renders earthenware vessels suitable for holding liquids, sealing, and inherit porosity of unglazed biscuit earthenware. Basically, glazing is the process which usually strengthens the material and give different properties like shine or luminance to the object. So this uranium isotope is being used in glazes and wall tiles. Then we have Purium 238, and this isotope is used as a thermal generator, or we can say as heat generator. So this radioisotope is a thermal generator isotope. Then we have americium 241 isotope, and this americium 241 isotope is used as a smoke detectors. We have curium 244 Cm 244 isotope, and this isotope is used for the analysis of pit mining and drilling slurries. Then we have californium 252 isotope CF252, and this is used as a luggage in a luggage inspection for explosive, in airports or in different screening sites. Different explosive materials can be brought to different countries by hiding them in different bags. So this isotope is being used as a tracer, and this inspects the luggage for explosives. And again, it is also being used as a soil. Uh, it is also being used to determine the moisture content in the soil. So these are all basically the industrial uses of different radionuclides. Then we have another application, which is the determination of flow rates and liquid volumes. So different industries uses involve the determination of flow rates and liquid volumes. In a former application, one introduces the tracer into the liquid stream by either pulse or continuous injection and measures the activity as a function of distance. So basically, different liquids are being flowing in different pipes in different industrial units. So the flow rates of those liquids present in those pipes can be determined by using different radio tracers. We can we can introduce the radio tracer along with that liquid, and in this way we can determine the um, activity of the radio tracer, uh, and that radio tracer can be introduced into the liquid streamline by uh, different processes like injection or by pulse method, and in this way the activity can be determined as a measure of function distance, or as a function of distance the activity can be measured. Uh, we should be careful to begin a sampling beyond the mixing region where tracer and fluid mix, This is done by beginning sampling at a distance of approximately 100x the stream diameter from the point of injection. So basically we have to be careful during a mixing of our radio tracer along with that liquid mix, or we can say the liquid that is flowing in the pipes. When we are introducing our tracer, we should be very careful. um, and we should have begin the sample at a distance of 100x stream diameter from the point of injection. Now we have the radio use of radionuclides or radio tracers in wear and corrosion studies. Corrosion is basically a very disadvantageous process in which the uh, iron or steel starts corrode, we say it is corroding or rusting of iron takes place. So this rusting is not very good, and in this rusting it may cause a different disadvantages, like the aircrafts or the different parts of the machinery that are uh, mainly of made up of steel or iron materials. They may start rusting, and in this way they may cause damage to those heavy industries. So radio traces have different uses in those uh, corrosion studies. In the studies of wear tribology, one labels the part under study with a radionuclide. The radioactivity is concentrated on the surface undergoing wear by plating, diffusion, or ion implantation with a low energy accelerator. Basically we are implanting our radioactive substance or radioactive nuclide or radio tracer onto the body by different methods like plating, diffusion, or ion implementation with a low energy accelerator. And in this way the process or the harm or the damage that is being occurred on that surface can be analyzed or can be measured according to the activity shown by the radio tracer. And the lipid part is put in service, and typically one measures the radioactivity released in the lubricant as a measure of wear. Calibrations of the technique can be done to get the absolute measures of wear, like in the same way that part which is being implanted by the radio tracer is then analyzed, and the processes like radioactivity, basically in which the emission of radiations are being occurred, is analyzed or measured, and different calibration curves are again plotted in which the uh, corrosion process is observed by different calibrations, and in this way they can be detected. At the end we have the assignment for you people, and that is that you have to determine some more industrial perspectives of radio tracers. Thank you. This is all about the radio tracers and the industrial applications of radio tracers in different aspects. According to different aspects, the industrial applications of radio tracers are being studied in this lecture. So, thank you. This is the end of this lecture.